Hello everyone, I'm Dr. Pryia Hasan and I teach at the University of here in India in the Maulana Azad University at undergraduate, postgraduate as well as PhD level. But I'll be talking to you about how we've been actually working on James Webb in schools, and this is just part of my interest of actually talking to school students. So let's see about how we can actually do such things. So we often visit various schools to talk about James Webb, and depending upon the school, if the school has the time, then we actually have a hands-on activity teaching them on how to actually make telescopes. But if the school does not have enough of time, then you could just have a talk in which we actually explain to students what exactly is the James Webb and why are we also excited about it. Now, this can be done at various levels. That can be done at primary as well as secondary and higher secondary levels. And obviously, you have to adjust the pitch depending upon the kind of material that students have done in school at different levels, because certain things are known and unknown at different levels, and we accordingly pitch it. So first of all, we start off with the basic definition of what is the James Webb Space Telescope. It's an infrared space telescope. So what I actually like to do is to explain each of these terms in detail, in reverse. That is, what is a telescope, why go to space, and why do we need to study the infrared. So the first thing is, if you've had a hands-on session, then the students have actually looked through a telescope. Otherwise, you would explain to them a telescope, essentially being a light gathering instrument. It basically gathers light from instruments, from sources, and the larger the mirror, the larger is the light gathering power. And then the telescopes also do give you the very important property of resolution and magnification, and that's how that helps us to actually look at faraway objects. And I would definitely talk to them about Galileo being the first one to actually look at celestial objects with the telescope. And even if you actually look at the size of the telescope which Galileo used, which was not very large, but the results that Galileo got with that telescope were revolutionary. For example, looking at the satellites of Jupiter, which was a contradiction to the geocentric model, as well as then, for example, the phases of Venus, which is again, it was almost observational proof that the geocentric model does not apply, because otherwise you would not get phases on Venus. And then, for example, the craters on the moon or resolving Milky Way stars. So that could actually give them the importance of why do we actually need to look at telescopes. And then the simplest telescopes talk them a little bit about reflecting telescopes and how one has to remember that even in reflecting telescopes, a lot of effort goes into the kind of design that you actually give the telescope. Because yes, you do have a mirror which will collect the light, you focus it, but if you put it at the prime focus, then you'd have problems like you have in the Palomar telescope, where the observer is literally on all kinds of positions doing circus skills, while you could also have additions like a secondary mirror giving you a Newtonian focus. You could have a hole in the mirror where you actually put a convex mirror, get a Cassegrain focus, or you add another mirror, a Coude mirror, to give you the Coude focus. And how this is also very important depending upon the kind of back-end instruments you have for your telescope. You may accordingly want to change this. And I love to tell students about how designing or innovation in telescope making is a very important art. And it is very important in the design of the telescope and how we actually put back-end instruments and use the telescope. So you could also see to it that you could put multiple instruments, back-end instruments at the same time, accordingly by using tertiary mirrors, secondary mirrors, and redirecting your light accordingly for observations. The next important aspect is to talk about the space aspect, and we talk about the atmosphere and how the atmosphere actually protects us from harmful rays, for example, X-ray rays, ultraviolet rays. But therefore, if we want to actually observe in the X-ray, it becomes essential to go out in space. And therefore, though the atmosphere actually protects us in that way, but if we want to look in different wavelength bands, we actually need to go out in space for X-ray, ultraviolet, parts of the infrared, and microwave, etc. So here we actually talk about space. For certain wavelengths, you have to go out. And then the other important thing, which is diffraction limited seeing, the highest to highest high school students do know a little bit about diffraction, but the younger ones can be explained basically about how images go blurry because of the atmosphere. And if you go out in space, you won't have this thing. Then the other important thing which they easily understand is the observing time. Ground-based telescopes have limited observing time, but if you're out in space, you do not have to worry about the day-night cycle. And for example, that these telescopes can be a survey mission and an observatory mission, and how even they or anybody in principle can actually observe with the James Webb by actually putting in proposals. Basically trying to show them how there's a certain level of democracy and freedom in science where anyone in principle can use the best of telescopes depending upon his or her science case and justification. The next thing I talk to them about is infrared. Why do we need infrared? It's essentially 700 nanometers to 1 millimeter. Herschel discovered it. What is actually infrared, and where is it actually used? What is the importance of infrared? Maybe a little bit about black body radiation and who emits in the infrared as being good infrared emitters. And basically, why does James Webb need to do infrared? Because James Webb is essentially a telescope to look at origins. And if you want to look at origins, you are, for example, looking at young stars. They are going to emit in the infrared. You're looking at high redshift objects. Their optical emission will be now in the infrared, and various reasons why we need to do that. And then I talk a little bit about the first light images of James Webb, so showing them the Eta Carina as well as Stephen's Quintet, SMAX, as well as this thing. So it covers most of that. And then we talk about a little bit about the future, that then you have the Raman Space Telescope, which would be the successor to James Webb, and how a little bit about Hubble, because many of them have heard about Hubble, comparing James Webb with Hubble, and how development in science, another very important essential thing, is about the engineering or the instrumentation of these instruments, that this is really cutting edge instrumentation and engineering and the kind of things that have been used for James Webb. So I think I try to make them convinced that astronomy not just includes looking at stars, it also includes a lot of stuff about innovation in telescope building as well as high-end engineering. So thank you.